Welcome back to the channel. Today, I'm honored to speak with Dr. Mitra, Associate Professor of Instruction in the Department of Computer Science at the University of Texas at Austin. Dr. Mitra has been at UT Austin since 1980 and has a rich background spanning astronomy, scientific computing, and teaching. He also teaches computational astrophysics to high school students, and I recently had the opportunity to work with him during this summer research program at UT Austin. My research was focused on solar flare detection. We'll be diving into Dr. Mitra's academic journey, his approach to teaching computer science, and advice for students who want to explore this fascinating field. How's your summer been, Dr. Mitra?
It has been very productive, and I was really impressed by your HSRA class and especially the work that your
Mhm.
group has done on solar flares. I hope that you get a chance to publish your work.
Thank you. So before we actually get into the deeper questions, I'm gonna ask you some rapid fire questions. You just answer with the first thing that comes to mind. All right?
Absolutely.
All right. Coffee or tea?
Boba tea,
If you weren't a professor, what would you be doing?
research scientist at NASA,
Early bird or night owl?
early bird,
Books or movies?
books.
What is one fun fact about yourself most people don't know?
I've tried playing several musical instruments, starting with the violin, accordion, piano, and I failed in all of them.
Wow. What's your favorite thing to do when you're not teaching or coding?
Fishing,
Algorithms or data structures? Which do you
algorithm,
enjoy teaching more?
al-
Algorithms?
definitely.
If you could sit in a room with Alan Turing or Albert Einstein, who would you choose?
Albert Einstein.
What's your favorite programming language and why?
Python, because of the simplicity of its syntax, you can write all of the syntax of Python on one side of one sheet of paper.
What's the most fascinating idea in computer science you've ever encountered?
That there are classes of computational problems that cannot be solved ever, even with the most powerful supercomputers.
And how's that? How does that happen?
It is the way that the problems have been defined. Uh, and there is one problem which is the poster child for this class of problems. It is called the halting problem. And
Mhm.
it will take a little bit of time to explain what the halting problem is.
All right. You mentioned in class that we're great grandstudents of Albert Einstein. Do you want to tell the audience that story?
Absolutely. So, Albert Einstein was a Jewish scientist working in Germany at the
Mhm.
turn of the 20th century. When Hitler was formed the Nazi Party, Albert Einstein knew that the days his days in Germany were limited, so he made the wise move to come to the U.S. and he joined Princeton University. One of his students was John Archibald Wheeler, and John Archibald Wheeler also worked on the Manhattan Project, which developed the atomic bomb. After that stint with the developing of the atomic bomb, John Archibald Wheeler came to the University of Texas at Austin and he established the Center for Relativity. When I came here as a student in 1980, I took my general relativity courses from John Archibald Wheeler. So I see a direct linkage from Albert Einstein to myself. And if John Archibald Wheeler was a student of Albert Einstein, then I call myself the grand student of Albert Einstein.
Mhm. That's really interesting. All right. Now that we've learned some fun facts, let's rewind the clock and talk about how your story began. You're originally from India. How did your early experiences there shape your passion for science and computing?
I grew up in a culture that valued the pursuit of knowledge over the pursuit of wealth. And that naturally gravitated me towards science and later on to computing.
What was it like studying under someone who had learned from Einstein?
It was very inspirational. He represented the best in the classical tradition of physics. He set a standard in the inquiry of natural phenomena that I have not been able to emulate even now.
What inspired you to transition from astronomy into computer science and instruction?
See, computer science allows me to do research in astronomy without having access to large telescopes. Having access to large telescope needs grant money, which is hard to come by, whereas
Yeah.
there is lots of available data from these telescopes that I can have for free, and I can work on it just as other professional astronomers are doing.
You've been part of UT Austin since 1980. How has the university and the field changed since you began?
The UT Austin is now much more diverse than it was in 1980. The field of computing has changed dramatically. Much of the earlier research that we did in the 80s was focused on computer architecture and operating systems, and now it is centered on artificial intelligence and security.
Also, I remember you mentioning class when you were going to UT Austin in like 1980s, 1990s. There was like a single computer, right?
Yes, I first came to UT Austin, there was only one computer. It was the Cyber CDC, and it was considered a supercomputer. And all of the people, researchers in UT Austin, used that one computer.
That must have been difficult.
It was time consuming, to say the least, but we did great science.
Yeah, I'm pretty sure. Was there a defining moment or teacher who pushed you to pursue science and education?
See, when I was about 12 or 13, I watched a show at the Birla Planetarium in Calcutta on quasars. And the presenter explained that the high redshift of quasars indicated that they were moving very fast. And I wanted to understand why the quasars were traveling so quickly. Because
Hmm.
at that time, no one explained to me of the expansion of the universe. Even now, it is a mystery to all of us as to why there are so many quasars uh, at in the distant past, but we don't see any quasars right now in our neighborhood.
Interesting. What advice would you give to your younger self back in high school?
You know, what I would say is don't be afraid to take risks. The future is much brighter than you think.
That's an interesting take. Your path blends astronomy, computer science, and education in such a unique way. Let's shift into the technical side of your work and how you bridge these worlds. You teach computational astrophysics to high schoolers through HSRA. What does that course cover, and how do students engage with it?
See, in my computational astrophysics course, I cover the foundations of astronomy, programming in Python, and fundamentals of data science. And we do this through a mix of online classes, lectures, and assignments.
Hmm. Is there like a specific experience or student that really, what's the word, like outshines the rest of your experiences with HSRA?
You know, one of the things that I have insisted on in my class, and the students are also taken by surprise, that you don't have to ask very deep questions to get meaningful answers. So I pose the question, why is it dark at night? And people give me the obvious answer, because the sun is not there. But when you start examining the answer to that question, we realize that the answer is not that simple. And if we live in an infinite universe with stars or galaxies being distributed uniformly in space, the sky should be blazingly bright, and yet it is not. And it and then when we start examining why that is, because that is a paradox, the sky is still dark at night, we realize that the problem lies in a concept of infinity. And I say this to my students over and over again: the universe does not care one whit about what we think.
Yeah, you mentioned that phrase a lot of times in class. Yeah, that's a key takeaway for me, honestly, from the class. The universe does not give one whit. Um, how do you integrate computer science into astronomical or other scientific research?
So you realize that all of the data is freely available. You can download it on your laptop. The tools to analyze are freely available. So what we do is we apply simple statistics and machine learning models to large astronomical data sets, and we try to get meaningful results out of it.
So could this apply to like other fields then, like biology, for example? If there's data sets, could you use computer science for that as well?
Absolutely. You can apply this technique to any field where there is a large set of data.
Could you break down how you use scientific computing to model complex systems, whether in space or in code?
Absolutely. So the first thing starts with the research question. What is it that you're trying to do? So the first step is to analyze the problem. And analysis in this context means to understand what it is that you're trying to solve. Then you look for algorithms that can solve the problem. So you take the problem, divide it into subproblems, and figure out the algorithms to solve each of the subproblems. Then the most important step is create test cases for your solution. What test cases means is, how do you know that you're correct? Just because your program gives you an answer, you don't know whether it's correct or not. So you have to create test cases to, to find out whether the computation is correct. Then you code the algorithm and you debug the code. Then you run your algorithm, you get the results, but that's not the end. Then you compare your results with what others have done, and to see whether this is reasonable or not.
Is this like a general application you could use for like,
It is a
you
general
know,
application that you can use for any complex problem.
your past work involved parallel computing, cosmological visualization, and natural intelligence algorithms. Could you explain those in simpler terms for us?
When I started my research career, I started with a very simple question. It is as simple as, why isn't the sky dark at night? But for me, the question was, what does the universe look like? And I applied concepts from computational geometry to create three-dimensional models of galaxy distribution to understand the nature of space. I used parallel computing, meaning utilizing more than one processor on a single problem simultaneously for the more complex parts of the problem. And I also use machine learning models to interpret the data.
What are some current problems in computer science that excite you the most?
I'm really excited about the application of AI to non-traditional problems in liberal arts and music.
So like AI creating music or what
Yes, AI
specifically?
creating music. So I'm looking forward to the day when you will have a channel like similar to Spotify, and you say, "Hey, produce the music in the mode of Beethoven," and it will go and create a symphony and play it for you. The symphony that has never been created thus far, and it's on the fly, produce music. But a more important application that I'm looking for is AI being given historical events and see if they can make predictions of the trend in which these events will take place. So we have enough historical events that we can use to train our model and to see what predictions the model can will make.
So I can see that use case, right, for the historical events in AI. But how would you like test the AI to see if it works, right? Because we don't know 100% like the correct chronological
We won't be
order.
able to tell in real time whether it'll work or not. For example, uh, you have certain economic theories being put into place, and you feed that to the model, and the model makes a prediction, and then you wait a few months to see whether that prediction is correct or not. And so, and give you, and if it is not, you go back and tweak the model until it is true, and then you feed some other events to see what type of prediction it makes until you're certain that the model is giving you the right prediction.
Yeah, that's interesting. How important is it for students to learn languages like C++, Python, or Fortran today?
I think every student should learn programming. I mean, I'm biased. I think it is essential as reading, writing, and arithmetic. The three R's that was developed a century ago.
So when you say every student, as in like even if like let's say you have a student who's going into maybe
Yes,
art,
I would say you should start in elementary school. There's nothing
uh,
that stops you from learning programming in elementary school. Instead of the students they're playing games, video games in elementary school. It's just a matter of learning how to code. I mean, I don't see that as being very difficult.
that's fascinating. So um, but what would the benefit from this be? Like every student from early age learning coding.
There's a tremendous benefit in learning how to code, and that is logical thinking. And because when you write a code and it is not logical, it's not going to run, and it forces you to write code in a logical manner. So, if at the very early stages you can get students to think logically through a problem, and even if it's a very simple code, they are learning how to think logically.
That's great. Doing your research goes hand in hand, right, with your role as a teacher and mentor. So let's talk more about your career as a teacher. So you've been recognized for your excellence in instruction. What's your philosophy when it comes to teaching complex topics like computing or algorithms?
I have a very simple philosophy: start with the complex topic and then break it down into a set of subproblems. Then present the subproblems as puzzles to be solved, get the solution of each of the subproblems, then weave the solutions of all of the subproblems together as a one whole, and that becomes the solution to the complex problem. It's basically what I would call a top down approach to problem solving.
Yeah, and honestly, that could be applied to a lot of things in life if you think about it.
Absolutely.
Like if you're trying to buy a house, you can think like,
Anything that you and to add, to break it down into small problems that can be solved easily, and then weave the solutions together so that it forms a solution to the bigger problem.
exactly. Um, what do you enjoy most about teaching high school students through HSRA?
The HSARA students are a self-selected group. I think they possess greater motivation and have a relatively clear block of time dedicated to learning and conducting research. And I've just enjoyed my teaching HSRA over the several years that I've been doing so.
Yeah, honestly, I also enjoyed, the class itself, meeting all those people, everyone I talked to. I didn't meet anyone there who was like, I don't like this class. So yeah. Um, you've taught everything from astronomy to computer science. What is most fulfilling about each?
You know, astronomy is grand and visually stunning. I don't think there's anything more beautiful than astronomy. It is also a field that people can connect to instinctively. There is curiosity in everyone when they look up and see the night sky. Computer science, on the other hand, is intellectually stimulating. It's not visual, but it is intellectual. And the problems in computer science are like solving crossword puzzles. So it appeals to those that like intellectual problems.
How can students who don't have access to formal research programs still start learning about computing on their own?
I would recommend that students learn a programming language like Python through online resources. There are many programs that are free. Then study algorithms. And then finally, they should work on independent projects. And a great site for independent projects is Kaggle, Kaggle. It has got lots of wonderful research problems that anyone can join and work on.
I haven't heard of that. You said Kaggle?
Kaggle.
I'll be sure to check that out. Can you share a student success story that has stuck with you?
Absolutely. In fact, I shared a letter from the student with your class. 2 years ago, I had the student in my HSRA program. And after the course ended, with my help, he published his research in a high school journal. Then last summer, he used that publication to get into a summer research program at Caltech. He published that research in a peer reviewed journal and presented his results in an astronomy conference, and then leveraged that in his admission application. So he had a track record of research, and he was offered admission to some of the most prestigious universities in the US. He will be attending Princeton University this coming fall, and he'll be majoring in astrophysics or physics, really, with an emphasis in astronomy and computer science.
For many students, learning from someone with your experience can shape their career path. So let's talk about where these skills can take them and what opportunities exist today. What career options do students passionate about computer science and scientific computing have today?
There are many. There are many career options for students interested in scientific computing. Scientific, and let's just talk about scientific computing and not other branches. There are four major areas I see an immediate application of scientific computing. The first is weather predictions and modeling. And it's absolutely necessary today, and it's going to be necessary tomorrow and the day after. Uh, the next area, analysis of stock data. There is a new field called quant, which is short for quantitative analysis. And that's where you would need analysis, scientific analysis of financial data. There is computational biology, where you are trying to understand complex biological systems using machine learning. And similarly, there is computational chemistry, where you can make different polymers, compounds using computational means. You don't have to be in a lab to make new products anymore. You can do the computation and create these products.
So this seems like there's a lot of applications then.
There are plenty of applications, but you have to have a very strong background both in the mathematics and in the analysis and computing.
So this next question kind of builds off the previous one and what you mentioned. How do you see AI and machine learning shaping the future of computing and education?
You know, when I was growing up at your age, I saw the shift from slide rules to electronic calculators. And everyone said that students are no longer will be able to do basic math in the head. Yes, we are not able to do that basic math as easily as our forefathers did. But we were doing more complex computations than they did. And I see AI and machine learning in the same way as a tool to understanding large, complex data sets. It's not going to do the thinking for us. And I don't think AI is going to take over the human mind, but it is going to be
Hmm.
used as a tool to understand more complex problems.
What interdisciplinary skills are valuable in modern computing fields?
You know, the one skill that every student should have when they enter computing is a strong foundation in mathematical logic. When you think of what computing is, it is logic. It is an application of logic. And I'm going to throw something else at it. I'm going to throw a completely different field where students should have some knowledge, and that is ethics. You should be responsible for the code that you produce, and there should be a very high ethical sense when you write code, especially in AI.
So when you say ethics, what do you mean specifically? Like, can you say AI, plagiarism?
Yes, uh, 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 when you are coding, and here is a question that I have not thought through, but the person who is coding should think through. You have seen driverless cars, and there is from Uber there is a spin-off called Waymo, and so somebody has coded Waymo, and here is the real scenario: the car is going on the street, and suddenly someone jumps in front of the car. That person has not seen the car coming. What should the software do? Run over the person to save the passenger, or brake the car, and the passenger in the car gets a neck injury or a body injury? That's an ethical question, ethical dilemma. Who should the software look out for? I don't have a solution, but these are things that AI has to, or the people who are writing the code will have to come to terms with.
Yeah, I mean, like, even for like just normal people, making that decision can be hard, especially in that like, split second, the person
Yes.
jumps in front and you have to decide. But then, also having to hard code a decision for an AI to do that can, yeah, I can see where there can be problems with that. Um, so speaking of opportunities, I know you've worked with or know of several organizations and programs that can benefit aspiring students. Are there any programs or organizations like HSRA or others that you'd like to promote or recommend to others?
Absolutely. There are. three that come to mind right now. Um, Research Science Institute at MIT. This is one of the best that you can get into. It's very competitive. There is the Simons Summer Research Program at Stony Brook, and there is also the Summer Science Program, which is an international program uh, in the US.
For students who want to start learning right now, resources can make all the difference. Let's talk about some of your recommendations. What books have deeply influenced your thinking in computer science or astronomy?
You know, these books are outdated and they were very influential when I was growing up. And I read a book called The Mysterious Universe by James Jeans. So James Jeans, he was a physicist that lived in the early 20th century. It's a dated book. I wouldn't recommend it, but when I was growing up, that was really something that became my inspiration. There was another book which was that straddled astronomy and computing, and it was called One, Two, Three, Infinity by George Gamow. And it introduced the concept of infinity. It introduced relativity, special relativity, general relativity, and it was fascinating of looking at the universe on two extreme scales, one very large and then very small. Once again, I would not really recommend the book, but they have been very influential in my own life.
So, even though they are, you said, kind of old, why wouldn't you recommend them?
You could read them. I would think just for, but many of the problems that they mention are not current problems. Like when Sir James Jeans wrote about the mysterious universe, there was no concept of dark matter or dark energy. And there's no mention of that. So he was talking about the science as it existed in the turn of the 20th century.
Okay, that makes more sense. Are there any online courses, platforms, or tools that you think are especially good for beginners in computing or scientific modeling?
Yes, there are lots of good courses, and many of them are free or almost free. There are good courses in LinkedIn Learning, Coursera, Kaggle. If you want paid subscription, I would recommend Brilliant, and they have very good courses. I think for $100+ subscription for a whole year, you can access any of the courses and learn most of the material.
Is there anyone in particular that you use a lot um, at your level?
Yes, I use Coursera, and then but see, for me, LinkedIn Learning and Coursera are free. It comes with my teaching at UT.
Interesting. For students looking to explore topics like coding, data structures, or computational physics, where should they begin?
They are free textbooks, and OpenStax organization has lots of state textbooks, and people have been laughing about OpenStax in our class, but they have done a great job in introducing material for free, and you can go and read up on any subject matter, not any, I would say, but STEM fields for free.
Yeah, I mean, yeah, a lot of kids were joking, but I did them through it quite often throughout the time of the course. And when we were actually working on our final research project, um, it was really helpful in getting me to start like what actually are solar flares at a deeper level.
Yes.
So, looking ahead, computing and AI are advancing at an incredible pace. I'm curious to hear your thoughts on the future. With rapid advances in computing and AI, what developments are you most excited to see in the next 10 to 20 years?
I already talked about it. I'm interested in seeing AI being applied to traditional liberal arts fields like history and music. I'm interested in seeing AI being applied to medicine, or being used to diagnose as a tool, mind you, as a tool to help doctors diagnose diseases, uh, going through medical reports and help doctors diagnose. And I'd like to see it create music, write novels, and as I said, help patients.
So, from what I've heard from other people, there's like kind of two sides to the coin. One is like AI will help a lot, like you mentioned, medical, liberal arts, music. But on the other hand, I've heard people say, like, express concern, right, that AI could completely take over their job or remove creativity from certain fields like music, like media, like videos, like movies. So, what's your stance on that?
I don't think that's true, because when computers came along, came by, people thought that there would be no need for mathematicians and people working in statistics. But that's not
Mhm.
true. We still need people in mathematics, and we still need people in statistics. We are using the computer as a tool. It's effective as a tool. It cannot take over thinking. If you, that's why you call it a computer. You don't call it a thinker. The thinking is done by human beings. So certain low level tasks will be taken over, and that's okay. I think that's how it should be.
That's an interesting take. What legacy do you hope to leave as a scientist, educator, and mentor?
I hope to create a generation of self-directed learners and problem solvers. It's as simple as that. I want people, and I've emphasized this in my class, I want you to be self-directed in your learning, and you learn how to solve problems.
What impact do you hope to have on the next generation of thinkers and coders?
I want my students to examine the foundations of physics and astronomy using the latest data set and rebuild it with the tools that we have. That would be something I'm hoping that I'm able to produce. Students that are able to do that.
So this kind of transitions us into our last question. What is one piece of advice you'd want to give to a student who dreams of making a difference through science or computing or even in general?
I would say have strong trust in yourself, but also maintain enough checks and balances so that you do not go off the deep end.
All right. Thank you so much, Dr. Mitra, for coming out for this interview. I hope you have a good day and rest of your summer.
Absolutely. These were wonderful questions, and I really enjoyed talking to you, Shivank, and I wish you the best in your journey in whatever field that you choose.
Thank you. Thank you.